Welcome back to Passionately Catholic. I am Anthony Digmann, and welcome back to another one of the videos in our series here where we are doing some analysis of some sacred art. Okay, now we got a little bit of a twist here on this one. Okay, like this is not, not really sacred art. We have another one on the Vatican. That's a photograph. Okay, it's not really sacred art, but I mean this is the Creator's art. Okay, like par excellence. And we are. I mean, like we're the highest thing in God's creation. Humanity made in God's image and likeness, of course. But I want to include this image. Okay, so this was a photograph taken, I'm pretty sure, by the Hubble Space Telescope. This is courtesy of NASA, in the public domain for use by, well, I think everybody, but at least by citizens of the United States of America, the good old taxpayers who make some of this good work possible. So this was another one of the images which I've shared, for a while, that a lot of these images I hung in my classroom, and I wanted to make sure that they were in the public domain so that I could blow them up to 2-foot by 3-foot posters and then hang those in my room. And this is another one of those. One of the names for an image like this, I had this cropped down for the particular use that I wanted in my classroom, but I think the original was titled Pillars of Creation. And I don't know what nebula this is in or any other details. Those of you who are watching, this is a quite famous piece, and again, it's a much larger image that was taken here, and this is a cropped out portion of it that I really enjoyed for the 2-foot by 3-foot horizontal poster that I wanted to have created on this. But if you know more about this particular image, please let us know. Let us know where we can find the full version and make that available for us if you don't mind. But okay, so God's creation and the beauty of God's creation and the splendor, is just, it blows me away. It just absolutely blows me away. If you would have asked me when I was in 8th grade what I wanted to do when I grew up, I would have told you I wanted to be an astronomer. And even at 8th grade, I was already looking into astronomy programs. I'm originally from Eastern Iowa. I was looking at a program in Wisconsin. At the time, the University of Colorado Boulder had a strong astronomy program, so I was looking into that as well. As I got further into high school, I realized how much math was involved, and I certainly liked math, but I had a little bit of an issue one year in a course that I took that kind of set me behind just a little bit in some of my math for a few reasons. So I didn't quite love it as much. And then I switched to history. So by the time I graduated high school, I was pretty sure, well, a little bit before that, I was pretty sure that I wanted to be a history teacher in high school. I just absolutely loved history, right? What I eventually realized is what I've loved so much about history and what I love so much about astronomy and cosmology is God, is God's work throughout history and the church, but also God's work in creation. So that's something I really enjoy doing in my apologetics class at Beckman Catholic High School. With the seniors that I teach every year, is looking at evidence for God, and a big part of that is God's creation. The Catechism of the Catholic Church says that we can know of God simply from His creation, have proof of God, evidence for God in what He has made, right? Like just the artwork itself reflects the work of the Creator. So in this particular piece, I love the colors. I love the brightness of some of these ridiculously bright stars that are around the outside. I love the depth of field that you have, in the background, and as you get to the smaller stars, it doesn't quite have the same depth of field as St. Peter's Basilica image that is also one of our sacred art videos that we're doing an analysis on, with the leaves in the foreground. There's not a foreground here. We're peering out from the Hubble Space Telescope. I'm pretty sure it's from Hubble, but I like the detail of these pillars of gas, like a nebula, I suppose. I'm not sure I'm using the accurate scientific terminology for all of that, but just how enormous, ridiculously enormous each of these fingers are, okay, and the gas plumes that each of these are. Like even if you look, the taller plume, which is more or less in the center, slightly to the left. If you look to the lower left of that, there's this, I don't know, like a little gas ball, okay, cloud piece, and that thing looks, tiny and itty bitty in this image, but I'm sure that is like huge, okay, in size. If you know astronomy well, and you know maybe about this image or more details about this image, I want to know how big that is. Like it looks way bigger than, maybe even bigger than the solar system. I just have no idea exactly how big that would be, but these things are just even that little piece, absolutely enormous, okay, in size, and really show the splendor of God. One of the previous images that we had looked at was the Pieta and the light coming down on Jesus. We also made the comment, or I made comments in the St. Peter's Basilica and the Rome image and the Tiber River of St. Peter's Basilica and the sun, which is next to St. Peter's Basilica, and light. Okay, and in this image, you really have, kind of based on the rule of thirds, like in the top third, if you will, you have this bright light, and it's not the way that I had this crop for the poster. It's not on one of the rule of thirds intersections, but it's on that top line. You really have the brightest essence of this image. Just really reminds me of heaven, God's glory, God's grace pouring out. And there's stars all over in there. If you zoom in and take a look at this a little bit more closely, there are stars in this nebula that are just bursting forth. And this really takes me again back to evidence for God, stuff that I share with students in my theology class, as well as I do a 3-talk series. If your parish is interested, this would be a great thing to do. Is I do one talk on why God, and then why Christian is a second talk, and why Catholic. So I go through the evidence for why we believe in God, the evidence for why be a Christian, and then the evidence for why being a Catholic. Great for a day of renewal, that we could do a retreat at your parish on, say, a Saturday, maybe Sunday. We could do a couple talks. It could be a morning and kind of more compact, or we could spread it out throughout the day, kind of start like at 9 a.m. and go through the Mass of Anticipation on Saturday night with confession in there and adoration in there. So the days of renewal are something that I'm offering and doing more of, trying to get Catholics together and, do a day kind of retreat together. Because so often, we Catholics, we don't go to retreats, so why not bring the retreat to us? We can do this, in today's world, bring the retreat to our parishes and make big stuff happen for people in our parishes and for ourselves to attend as well. So yeah, back to that. So something that I talk about in that Why God talk and in my apologetics talk is God's order, God's structure in creation, how he creates. One of the arguments for God is, a simplified term that I like is God is the first cause. Okay, so God is the thing from which everything else comes. He got the whole chain of events, right? Like everything that happens is an effect that was caused by a previous cause. Okay, so you get this constant chain of events which were caused by a previous cause, and then you go all the way back to what? And you go back to what science is indicating to us is the Big Bang, okay, that there was a singularity, an event, if you will, that everything else spilled forth from, right? And here you have this nebula, it gives me this reminiscent feel for like a Big Bang and an early universe, if you will. Now, you wouldn't have had the stars, like that took time for that to happen, but especially with these big gas plumes. So let me kind of describe real quick. This ties into another argument for God's existence, like a intelligent designer, like God's hand had to be involved in the process. And when I say intelligent designer, there's a couple different ways that people mean intelligent designer, and one of the ways gets critiqued pretty ferociously sometimes. The way that I mean intelligent designer is that there had to be an intelligence behind the creation of the universe and the way that it came together. I'm not talking about a creationist intelligent designer, like a literalist that God created in 6 days, but an intelligent designer piece that God is the intelligent designer that works with what we know from science. Big Bang, like Big Bang theory was proposed by Father George Lemaitre, a Belgian physicist and priest. I mean, he's a priest for crying out loud, right? So the Big Bang is not a theory that contradicts our Catholic faith or anything like that by any means. But one of the pieces of evidence for this is when the universe began with the Big Bang and you have this explosion, that there is a very carefully fine-tuned, you might say, relationship between many of the forces, if you will, or parameters, probably is a better way of putting it, in physics, okay, that are sometimes called anthropic coincidences. Things that are fine-tuned, that are tweaked just right, and they could be otherwise, but they're fine-tuned just right so that life can exist on Earth. And a couple of those are, when this explosion takes place, that the explosion power of the Big Bang going boom out, and the breaking power of gravity, which is pulling back in, which is trying to attract, gravity is just molecules being attracted to molecules and pulling back together, that those two forces, those parameters, had to be precisely calibrated, especially at the beginning, for the universe to have even worked in the first place, okay? So on one end, this is an easier end to explain and to understand, is if the exploding power had been a little bit weaker in the Big Bang and the force of gravity was the same, or if the explosion power was the same as it was, but the power of gravity was increased so that molecules just are attracted to each other a little bit more than they currently are, you would have had an implosion. The creation would have gone boom, it would have gone out, and then it would have imploded rather quickly, okay? Versus, okay, so what ended up happening in our universe is you get this explosion, and then you have hydrogen atoms, you have helium atoms. That's 1 and 2. What are 3 and 4? There were just a few of the early elements, or a few of the elements, the first elements from the periodic table of elements. You have, what did I say? Hydrogen, helium, lithium, I think, beryllium might be the fourth one. Correct me in the comments, you guys. Fix anything that I'm saying wrong here. You would have had a lot of helium, a good amount of hydrogen. I'm sorry, it's the other way. Lots of hydrogen, little bits of helium. If lithium is number 3, you had a little bit of that. And then if beryllium is number 4, you had a very little, of that, not as much of that, right? But these are the elements that we have for the whole universe. So basically you have right after Big Bang, or shortly after Big Bang, if you will, relatively, you have these gas clouds, right? Now, if the Big Bang had been a stronger power, stronger explosion, or if the force of gravity had been weaker, you would have had what was called like a heat death of the universe. You would have had these molecules would have spread out, and these molecules might have attracted a few other molecules together due to the force of gravity, but they wouldn't have been able to get like a big star going, okay? It just wouldn't have been enough. Maybe you would have gotten some stars depending upon how, calibrated this stuff is. But it eventually, it all just would expand out, okay? And you wouldn't have gotten stars, planets, stuff like that to work with, okay? So it totally wouldn't have worked. You had to have had an intelligent designer to fine-tune the explosion power of the Big Bang and the force of gravity to hold it back together. So here's what ended up happening because those were so carefully calibrated. And this is, looking at this image, it makes me think of all this incredible beauty of creation and the fine-tuned calibrations that God must have done to make life possible, especially human life possible, is that this explosion takes place, right? And you get these gas clouds, and the hydrogen molecules, and then helium too, they start to collect due to the force of gravity, and they're not being blown apart so fast that they can't do that. So they're able to collect to each other, and once you get them going, they develop more mass, and then they have stronger gravity as a group, and then they pull more and more and more in. And when you get enough hydrogen atoms, okay, and there's going to be some helium again, and I think lithium and beryllium, if those are number 3 and number 4 on the periodic table, those are going to be in there a little bit too, but mostly hydrogen. You get a big enough ball of hydrogen gas, and it ends up being so dense in the center due to gravity and creates so much pull in there. It generates heat, and then it starts on fire. And then what do you have? Then you have a star, okay, right? And it's burning through this hydrogen. Well, this is another fun fact from science class, if you will, that also I think has beautiful ramifications for our faith, is as stars burn, okay, they burn through the hydrogen, and they're actually creating other elements. These are being fused together, or I can never remember if it's nuclear fission or nuclear fusion that happens in stars. I think it's nuclear fusion. But you have these different elements being actually created in stars. So at the dawn of the universe, okay, and we're not just talking the solar system, we're not just talking the Milky Way galaxy, we're talking the universe. Everything that we know that exists, okay, and have proof to scientifically prove that it actually exists, is in the universe, the known universe, okay, boom, right? So this is, and the universe began, if you will, I'll use that word, with the Big Bang, okay? So you have these stars, okay, and they're burning through their hydrogen, And they're creating the other elements in the periodic table of elements, okay? Like as a general rule of thumb, creating carbon, which are all life on Earth is based on. We're carbon-based life forms. Creating oxygen, and making other things possible, like H2O, right? So water becomes possible once you have oxygen to be able to work with. So there's all these other chemical compounds, these other elements are created, make all these chemical compounds, chemistry, possible, okay? So these are being created in the star, right? So the star burn. So it burns through the hydrogen, and then it switches to the next most efficient thing to burn, the helium. So then once it burns through the hydrogen, it starts burning the helium, which is going to be less efficient. It's going to do that more quickly, and then it's going to burn through any other elements after that. It's just going to go down the line. And this ends up, if the star is big enough, right? And the only way to pull this off, again, is to have your gravity at the time of the Big Bang, or shortly after the Big Bang. You've got gravity and the exploding power of the Big Bang precisely calibrated in such a way that enough molecules can come together to create not just a star, but you need a big enough star that when it reaches the end of its life, and it's burning through these last few elements that it's able to burn, it can no longer sustain its own size, and it collapses in upon itself and explodes again, reverts back into an explosion of a supernova, right? When it goes supernova, all these other elements that were created inside of that star due to the nuclear fusion, I think, okay, could be nuclear fission. Somebody correct me on that one in the comments and let us know the difference. But those are created inside. When it goes supernova, okay, those get exploded. Okay, and they go out into big cloud, okay, like this. And here's where we're coming back to our image. Is you have this nebula here, if you will, these gas cloud, but it's also going to have, because now you're not in the first generation of stars. The first generations of stars, remember our universe is maybe 13.7, 13.8 billion years old. Star might live several billion years. Once this first generation dies, the stars that go supernova and blow all these elements out around them, it's the second generation of stars that have the possibility of creating systems that could have life on them, okay? Not the first generation, not carbon-based life forms, because there's no carbon in the universe, and things like that life as we know it needs to survive, like water, H2O, you don't have the oxygen to work with yet, okay? You got the hydrogen, but not the oxygen. So you need second generation, you need stars to go supernova, create these elements, and then blow them out there. It can't be a smaller star that maybe like our sun, like a medium-sized star, it's going to swell up eventually. It'll become a red giant, okay? So it'll swell up, I forget exactly how far out. So it'll swell out to the size of maybe it's Venus, or maybe it's past Earth's orbit. Maybe it'll even get to Mars, I don't know. But a big red giant, and then it'll shrink back down, and it'll be a white dwarf for a while, smaller than the yellow sun that we have now. It'll be a white dwarf, and then eventually it'll burn out, okay? And it'll be a leftover, like black dwarf, kind of a heavy, incredibly heavy, dense ball of the elements that are left over. Okay, but those elements, that's not going to allow life to be created, because anything in there, like the iron and the nickel and all that kind of stuff, the carbon is not going to have exploded out into the area around it so that new stars can form. Okay, but that first generation that goes supernova, and again, you have to have these parameters of physics perfectly calibrated for this to happen. Okay, you've got to have enough gravity, the strength of gravity has to be strong enough to pull all of these hydrogen atoms together to get a big enough star right off the bat, so that at the end of its life, it goes supernova, blows these things out, and then you got a gas cloud like this. And you can see, if you zoom in on these nebula, these gas clouds, you can see the stars even within them, okay, beyond them, but also within them that have spawned from these gas clouds. And these gas clouds could then have more in them than just gas, but could also, with the second and third generation of stars, could have oxygen, could have carbon, these critical elements for life to exist, right? And then you're able to get planets. So when these stars condense down, there may be physical material going around them that then collects into make, like in our solar system, you get asteroids, you get planets, all of those things that you would not have had in your first generations of stars, because those were almost just gas, okay? But you get those in your second and third and beyond generations, right? So our Earth then can have a nickel iron core that is able to spin. It's able to create magnetism. This is, another fun thing, an anthropic coincidence, if you will, an evidence of the Creator and the fine tuning of God. So you get the Earth with a nickel iron core, and it spins, and it creates an electromagnetic field known as, hey, I'm from Iowa. I was a professor from the University of Iowa. Dr. Van Allen discovered these, and these are named after him, the Van Allen belts. So these are electromagnetic belts that go around Earth, okay? And they protect us from bombardment of radiation and all kinds of cosmic dangerous material, especially from the sun. That could cause, horrible rates of cancer, all kinds of stuff. Like, life would not have been able to exist as we know it on Earth without the nickel iron core and the electromagnetism of the Earth rotating, spinning, and then developing an electromagnetic field, and the Van Allen belts protecting us from solar radiation and all this kind of stuff. And by the way, the Van Allen belts and the electromagnetic belts that we have are also what create the aurora borealis, the northern lights as well as the southern lights, right? Because electrically charged particles, maybe ions, is that the right word, are going to make their way down these belts to the poles, and then they're going to interact with gases like neon gas in the atmosphere that are then going to light up from these electrical charges from the sun, and that's when we get the northern lights and the southern lights. So it's a beautiful thing that reflects the Creator a little bit as well. So anyway, when I look at this image, there's a lot that I get from this image. So I cropped this down to this size, was really excited to be able to put this in my classroom as well. Hopefully this was a useful reflection on you of this particular piece. And sacred art, not in the human created sense, but sacred art in the sense of God showing us his creation, showing himself to us through his creation, and then what we have been able to realize and see. I think that you could say that science itself is if this is sacred art, if you will, God's creation, in a sense, not human created sacred art, but God's sacred art, his creation itself, then science, in a sense, and mathematics even as well, are a reflection upon and an attempt to understand the greatest of sacred art, creation itself from our Creator. So hopefully this was useful to you. If you want to be in for more of our videos, you guys, make sure to hit the subscribe button and click that bell icon so that YouTube will notify you when we post new videos from Passionately Catholic here. Thanks as always to all of our patrons who make everything that we do at Passionately Catholic possible. Thank you so much for making this video. Again, everything that we do, we couldn't do it without you, so thank you. I wish you all God's blessings and peace, and I will see you again in the next episode.